So good afternoon, everybody. My name is Jeff Watkins. I'm an iOS software engineer. I'm on the iTunes team, and I have the pleasure of talking to you a little bit about advanced user interfaces with Collection View. Recently, we got some brand new designs for iTunes Connect. And these were welcome new designs for iOS 7 look and feel. And they were really fantastic. They were brand new, fresh, clean look and feel. And they gave us a great opportunity because we have been making decisions for our code since iOS 2. And as you can imagine, the decisions that we made back in iOS 2 were really not the same decisions that we would be making today. So this was an ideal opportunity for us to take some time and pay off some technical debt. Now, we all know that that's fancy speak for throw away the old code and write some shiny new code. But the reality is, we really wanted to build a really great modern architecture that would take us forward a few more releases. You know, everybody thinks that they're going to build this shiny, glittering jewel of an architecture that's going to last forever. But the reality is, you get 2, maybe 3 releases out of anything you build, and then it's time to rethink things. But this was our opportunity. So I'm really excited to announce that we have some sample code that goes along with this talk. But what makes this sample code even more interesting is this sample code is distilled down from the actual source code of iTunes Connect. And I have my manager and his chain of management to thank for this, because this is kind of unusual. Normally, sample code is something that you just sort of whip together for your talk, and it covers the aspects that you're talking about. But it covers the bare minimum. This actually is full, rich data sources, full, rich UI collection view layout. And there's actually way more in there than we're going to talk about today. Plus, I'm sure there are bugs. But more importantly, we'll be building on it and improving it as time goes on. So look for all sorts of additions to this sample code as time goes on. So we had some requirements, just like you all probably get requirements with your applications. And I'd like to go through those one by one and take a look at them and give you a little bit of a sense of where we were coming from and a little bit of sense of the terror that I felt when I took a look at them. So first of all, we had really complex data. We started off with iTunes Connect 2 supporting apps and books. And that was great, but now we were going to support all of the content types that the store supports. So we were going to add music, as well as movies and TV seasons. Now, that was going to pose a significant challenge for us, because each one of these content types, as you can see, has multiple sections, multiple different tabs within there. We're talking about an awful lot of data that's going to be a real difficult time to manage. On top of that, we really wanted to have a single loading indicator. One of the things that I think is really tremendously important is that users know when the content is available and ready for interaction. I really don't like it when an application has a spinner here, a spinner there, and I don't really know if it's ready for me. So I wanted to make iTunes Connect really clear that when the spinner was gone, we were ready for you. So we were going to have our spinner, our spinner was going to go away, and there was the content. Now, most of our designs looked like UI table view, and this was easy. We could have done this in our sleep. But it got more interesting on iPad because we needed to support multiple columns. Now, we could have hacked together a solution for iPad, but that didn't feel right, right? Here we're trying to create a future-looking modern architecture. We shouldn't consider hacks. So we really needed to do something more sophisticated for iPad. And that's when I started thinking, let's take a look at collection view. Well, if you know collection view, you know there's some limitations with the standard flow layout. Specifically, it doesn't really support global headers like you have in table view, right? And we needed to support global headers. We needed to be able to have this one header that stuck around as you tabbed through your content. So that made me start thinking, I'm going to have to do something here, and I might wind up having to write my own layout. In addition, we also needed to support pinned headers. So as we're scrolling through our content, it was really important that we'd be able to get at those segmented controls so that we could get to the different sections of our content. So we needed to be able to support pinned headers, and flow layout also doesn't really support that either. So that kind of put the nail in the coffin of using flow layout for us. And that meant we're going to have to do a collection view layout, which I got to admit was pretty exciting. I also wanted to add swipe to edit. This was a new feature in iOS 7, and I thought it would be a great addition to iTunes Connect because it gives it that modern interactive feel. And users can then swipe, delete Xcode from their list of favorites, and move on. Also, if you've got a list of favorites, you're going to want to be able to edit those. So we wanted to support batch editing, and likewise, you can delete Xcode. Now, favorites wouldn't be any good, right, if you couldn't manipulate them, if you couldn't reorder your favorites, because it'd be kind of a drag if you got a lot of favorites and they're in the wrong order. So we wanted to support drag reordering as well. And we needed to support that with a custom layout, and that was going to be a bit of a challenge. But I feel like I've been slagging on Xcode, so I'm going to put it back at the top of the list of favorites, because they really have hit it out of the park. Come on. With Swift and all the other stuff they've been doing, those guys. So those were our requirements. And that was kind of a lot. I mean, on top of all the other stuff that the rest of the guys had to do. But I want to talk about the first one first, because without data, right, iTunes Connect is nothing. It would just be some pretty pictures of your apps and everything else, which are nice, but nobody's going to want to look at lines and pretty pictures. So getting the data right is the most important thing, and quite frankly, it was the thing that I was really, really convolutedly freaked out about, because 5 data types and all these different sections, and oh my goodness. So I really needed to come up with some way to minimize the complexity of all that data. And the way I took a look at this is I took all of the designs that our HI guys and gals, in fact, mostly a gal had come up with, and we laid them out, and I kind of squinted at them and laid them out side by side, and I realized that there were some real similarities here, right? If you squint at these, you realize that we've got some key value stuff going on here, and that in particular showed up all throughout the application. We've also got this status section that shows up frequently. And we've got lots of sections in our layouts that seem to reappear all over the place. And I thought to myself, gosh, this is really something that we need to take advantage of. We really need to be able to reuse this kind of code. But the problem is, if you've been doing collection view controllers in the past, you know that there's really challenges with code reuse when it comes to data sources. The traditional approach to a collection of view data source has you putting everything in the view controller. And as a result, you wind up with one of two things. First, you can wind up with a gigantic view controller. And I'm sure you've all seen this, not on your projects. But you wind up with a view controller that's like 5,000 lines of code. And it does everything, including things that you don't do anymore. I deleted all that code. And so we didn't want that, especially not, I mean, we're starting fresh, right? We wouldn't want that. The other option is we could have had one view controller for each content type. And that seems like it's a better approach, but it's really not, because there's really a lot of things that the view controller just does innately. And the way you wind up with sharing common code is you wind up pushing it down to a common base class, which winds up being the same thing as having one gigantic view controller because you've pushed it all to the base class. So sure, you've kind of hidden it a little bit, but now it's down there and you're just not looking at it. And it doesn't at all solve the problem of code reuse across screens. So we wanted a better solution. Now, fortunately, I had the pleasure of working on the Game Center team during the iOS 7 redesign, and they came up with a solution to this exact problem. It's called aggregate data sources. Now, their data was a little bit less complex than ours, by just a smidge, but they hit upon the right answer, which was building up data sources from smaller data sources. There's nothing that says that a UI collection view data source has to be implemented on your view controller. In fact, I would encourage you not to implement the data source on your view controller. In fact, I'd go so far as to say, never, ever again implement it on your view controller. I mean, unless you really want to. But what we do here is we implement it as a general NS object, and then we build those together to build a much more sophisticated data source. And this goes a long way to enabling code reuse. Because as you can imagine, we've got these little classes of data sources that we cobble together, and we reuse them all over the place. And as a result, we wound up with a single view controller for our product detail screen that has only 14 methods. Now, 6 of those methods, before you get all upset that I have 14 methods, 6 of those methods, 5 of them are building the 5 content types of data sources. 1 of them is building the overall data source. And then the rest of them are some action methods that bubble up our responder chain. I think there's some, delegate methods in there and whatnot. So, I mean, we do go a little overboard. I probably could have cut it down. But, we're getting there. So let's take a look at the 4 intrinsic aggregate data source classes that you'll see in the sample code. The first and most important one, where all the action is AAPL data source. That's the base data source. That's where we implement the UI collection view data source protocol, as well as a host of other good stuff that we'll talk about in a little bit. On top of that, we've layered the AAPL segmented data source. And that can have multiple children, but only one of them is active at a time. Think of a UI segmented control. In fact, there's a good reason to think of that. It will vend out a header with a UI segmented control as part of its base behavior. Then there's the AAPL composed data source. And that will take a number of children. They're all active at once. And it manages the mapping between the external index paths and the internal child index paths. And then there's this AAPL basic data source. How many times have you had just a list of things and you just want to show them? Well, that's what the basic data source is for. It takes an array of items. It manages insertions, deletions, reorderings, all that nasty stuff. It sends out the right notifications. It only allows you to have one section because there's countless times where that's all you need. And we wind up using it all over the place. So let's take a look at how we use these 4 classes to build up our product details data source. So first of all, the product details data source is a segmented data source. And it has 4 segments. No surprise, 1 for details, 1 for episodes, 1 for reviews, and 1 for trends. Those correspond exactly to the UI segmented control in the headers. That UI segmented control is actually created by the segmented data source. Now, the details child data source is a composed data source. And it has children for the status section, information, and description. Each one of those is its own data source. The information was one of those key value data sources. The description is a special textual data source. And all of these are pulling information out of the product object. Now, episodes is just one of those basic data sources, because we've just got a list of episodes. But this is where it gets interesting, because as you can see, episodes have a show date. Now, we could take the date and we could pass it off to the cell, and we could have the cell create an NS date formatter, and we could render it and do that. But we've been told countless times that that's really the wrong thing to do, right? So this is what data sources allow us to do, is we can encapsulate task-specific logic, presentation-specific logic. So in my episodes data source, that's where I have a date formatter that's specific to the episodes, and I do that conversion of the NS date that's in each episode into a string before I jam it into the cell. And that way, I get the best performance rather than allowing that to happen in each cell. Then reviews is another composed data source. You're probably getting tired of this, but it's great, let me tell you. And the composed data source for reviews has one for ratings and another one for the actual reviews. And we'll actually come back to the reviews data source when we look at how things load in the coming up slides. And then trends is a custom data source. It derives directly from the base data source, because we go out and we fetch the trend data, and then we actually render it in two separate sections, one for the graph and then another for the historical data. So that's how we build up a product details data source from all these little aggregate data sources. And that has an additional benefit, because remember I told you that we wanted to have a single loading indicator, right? Well, we originally tried to make our single point of truth for whether we're loading be the view controller. And that's kind of tough, because the view controller really doesn't know what all is being loaded, right? We've got 5 different content types, multiple sections with subsections within them. Each one loads its own content. How's it going to know? Well, it turns out we have one thing that knows about everything, and that's the product details data source. So the answer to the whole problem of who knows what's loading is the data source. The data source is responsible for loading its content. And when you think about it, it actually makes total sense. And if you make the data sources responsible, they know just the data they need to load, they know exactly how to load it, and they're already responsible for their own task-specific logic. So they can format it, do whatever they need to do, and make it ready for presentation. So now the view controller kicks off the whole process in view will appear by sending a load data to the data source, which in turn propagates that message to its children as appropriate. So for example, a segmented data source will only send it to the selected data source, but a composed data source will send it to all of its children. And because we're good computer scientists, just like all of you, we use a state machine to keep track of everything. You would, right? Let's take a look at that state machine. So the obviously named AAPL Loadable Content State Machine. It's got a few states. It's not as nasty as it could be. All data sources start off in the initial state until they receive a load content message. Once they've received the load content message, then they transition into the loading content state. That's when we display the spinner. That's the only time we ever display the spinner. And if you notice, you can't ever get back there. So when they get content, or they get an error, or they receive no content from their respective sources, they'll transition into no content, content loaded, or an error state. And we'll display the appropriate view. And we'll take a look at exactly how that works. So let's see how this all works from a data source loading data off the network and from a UI standpoint. So here we are in the initial state, and we've got my cat list data source. This is from the sample application because I am cat crazy. And yes, I was heartbroken when we switched to California landmarks. Yeah, I thought the ocelot was finally going to get its chance. So we're starting off in the initial state, and we get the load content message, and we transition into loading content. Then the data source, in this case, it's going to request out to its server, get me some cats. The server eventually comes back and says, here you go. Now, depending on what the response is, then it's going to make a transition into the right place. And let's take a look at what the UI does in this case. So here we are in the loading content. We're showing the spinner. And let's imagine we get back some cats. So here we're going to display the cats. Like I said, this is the sample application. Assuming everything works well, this will compile and run exactly as planned on your machines. And we'll see our list of big cats right there on our devices. However, if you know anything about cats, they're never where you expect them to be. So more than likely, you're going to try to load the cats, and you're going to be told, there are no cats here. Well, the great thing about this is I had to do no work here, which is great because cats do a lot of work for you. So in this case, all I set up was the no content message and the no content title on my data source. And behind the scenes, the machinery took care of everything else. When I transitioned into the no content state, the layout and the data sources take care of presenting the placeholder for me. It really takes a lot of the burden off of my shoulders. Now, sometimes things go wrong. And then we go from the loading content state into the error state. And similarly to no content, if we've configured an error message and an error title, we'll get a placeholder telling the user what's gone wrong. So this is a really great way that we found to get our consistent UI. But it's a little bit more than that, because in most cases, we're not just loading one thing, right? I mentioned we'd come back to the ratings and reviews. We load that information separately. We fetch the ratings, and we fetch the reviews. Well, we can't update, if we've got a single loading indicator, we can't update the collection view with the ratings and then the reviews, because that wouldn't look right. So we've got to update everything all at once. And in order to do that, we needed a solution that was elegant, because anything less would be just wrong. So the solution that we came up with relies on the fact that we have a parent-child relationship to our data sources. So let's take a look at that. All of our data sources start off in the initial state. They get the load content message, and they all transition into the loading content state, at which point the ratings and the reviews data sources send out their requests to the server. Now, we all know that the server is not going to respond simultaneously to both requests. That's fantasy land. So what happens is one of the responses comes back first. That data source will process the response, but not update itself. What it does is it queues up a block that actually will do the update, and it sends it up the parent chain. And that block will just sort of hang out there for a bit. Then the next data source will get its response. It does the same thing. It transitions into content loaded, queues up an update block, and then the parent will discover, oh, look, all of my children are loaded. It's okay for me to transition into content loaded. And now I can perform batch updates on the collection view and schedule all of those update blocks safely inside a perform batch updates block. The good thing about all this is we don't get exceptions because of our timing and inconsistencies. And I don't know about you, but I don't like exceptions. My boss gets really grouchy. So to recap, aggregate data sources were a great way for us to reduce our view controller complexity. Our view controller only does view controller-y things. It's no longer involved in the data source other than setting it up. And it went a long way to promoting code reuse. So now our code is scattered in these aggregate data sources that we use all over the place. And it isolates task-specific logic that we use for setting up our cells into the data sources where they're appropriate. And we got that single loading indicator that we were looking for. So that was our first two requirements. So let's take a look at the next four, which necessitated a custom UI collection view layout. Now I have a confession to make. The first time I built the layout, I was very unhappy. It worked. It worked actually really well. But I am, how shall I put this? Hard to please. And it didn't work as well as I wanted. And the reason is I didn't collect all the information that I should have. I tried to be done and just move on to other things. So the message I want you to take away from all of this, and I'm sort of skipping ahead to the summary before I even start, is do your bookkeeping. Get all the information you can, and at the very end, run instruments to make sure that you have enough memory and you're not using too much resources. And then prune back the information you're keeping, but keep it all up front. So let's take a look at the information I kept, the information I didn't keep, and what I should have kept. So first, what did I need to keep, and where did it belong? So obviously, we got these great designs from HI, and they're just pictures, right? We needed to interpret that and figure out what did we need from that to actually lay out cells and headers and footers and supplementary views and decoration views and the whole 9 yards. And then, kind of as a footnote, where does it all go? And I want to address that first, get it out of the way. Data sources vend visual information. They vend views. Design metrics are visual information. I put them in the data source. Partly because the data sources are hierarchical, and they've got default metrics, and they've got section-based metrics. It just made sense to put it there. I could have put it in a parallel structure, but then I would have had parallel structures, and that would have been too crazy. So they're in the data sources. That's where you'll find them. So let's take a look at the section metrics. So here we've got some big cats. And naturally, we're going to want to know the row height. We also want to know the background color, right? A lot of our sections can be gray. Some of them are white. None of them are garish colors. Obviously, we have some that have separators and separator insets, but not all of our sections have separators. So we needed to be able to set that on a per section basis. We also need to be able to set a selected background color. The way we determine whether or not a cell appears selectable is by the selected background color. Whether it actually is selectable is in code. Now remember, we also support multiple columns, so we needed to know, based on the section, how many columns it should support, and whether or not it should show a column separator. For the headers and footers, We similarly needed to know the height, although most of the time we set this to 0, which means figure it out yourself, thanks to auto layout. We also wanted to know the background color, but most of the time we set this to nil, which means inherit it from the section. And we also wanted to specify a padding, because one of the things that we saw in our designs a lot was exactly the same header, but with a little bit more space between this instance of the header and that instance of the header. And yeah, we could define a subclass to give us a little extra space, or we could just have another metric that says, oh, here we're going to have 10 points of spacing, there we're going to have 20. So we added padding. It actually wound up being hugely helpful when we needed to align things horizontally as well. So this gave us all the information we needed to lay things out in our actual layout. But some of this information needed to be passed along to the cells and the headers. And to do that, we had some custom attributes. And I'm sure you all know that you can create subclasses of the layout attributes. So that's exactly what we did. And we wound up with 4, plus a few more, custom attributes. First of all, background color and the selected background color, and padding, but also pinned header. At one point, we thought that we wanted our headers to respond to being pinned. For example, if we had had a navigation bar that was blue, it would make perfect sense for the header to reach the top pin and change to be blue. And it would need to know that it was pinned in order to do that. So those were the custom attributes we decided to define for headers and footers and our cells. Now remember, we also needed to support global headers. And to do that, I'm going to let you in on what I thought was a secret. It turns out it's not. We're all familiar with NSIndexPath, normally having 2 indices, one for section, one for item. Well, it seems that you can also create an NSIndexPath with 1 index. And when you do that, you're creating a global supplementary view index path or a global decoration view index path. It makes no sense to create these for items, so don't try. But this is how we separated our global headers from everything else. When we initially tried this, I tried to lump them in with section 0, and it just made no sense. So now I'm able to distinguish them from everything else, and we treat global headers differently. When you look at the sample code, you'll notice that the global headers actually never go off screen. They pin just underneath the navigation bar. They're treated as what we'll call special attributes. And they get updated as you scroll so that they stay in place, and they do all sorts of funny, fancy things. Now, the code needs to be a little bit smart so that you check the length of your index path so that you don't accidentally call section and item for these global index paths. But other than that, you're good. Now, building a layout. Earlier today, you might have heard Olivier mention that you want to be really careful about using invalidation, or you want to be really careful to use invalidation, I should say. And that's exactly the case. You might be tempted to build the most perfect single-pass layout engine. Don't. Because what you'll wind up with is absolute efficiency the first time. And then someone will come in, and the collection view will come in and say, hey, this cell has changed. And you'll have to relay out everything. Or the origin has changed because you've scrolled, and you'll have to lay out everything. And you'll just drop. Your performance will die. So let's take a look at the pseudocode, so to speak, for the layout that we came up with. And then we're going to show you a little bit of how we snapshot the metrics for one of our sections. And I think you'll get a good sense of why breaking this up into sections is really important. So first of all, if the data source has changed significantly, like it's a totally different one or the total number of sections has changed, we just throw everything away. And the reason for this is it's probably more efficient for us to just recompute everything than it would be to compute the deltas, because our data sources are actually pretty small. If you've seen iTunes Connect, you know that the actual content isn't that big. So yeah, I could probably have come up with a clever way to compute deltas and everything else, but this wound up being just easier. And in the long run, getting it done is sometimes just as important. Next, if the collection view's width has changed, or obviously if I threw everything away, then I need to regenerate all the layout attributes, as well as collect all of the special layout attributes. So all of those global headers and any pinned headers that might have been defined within the content. So I make that single pass, and I lay out everything. And then, if the origin has changed because we've scrolled, I update the position of any special layout attributes. Now, when I go back and I update all of this code to support iOS 8, I'm going to fix this, because I'll use the new invalidation context, and this will all be different. But this is how we do it today. So let's take a look at how we snapshot the metrics. So we have this hierarchical structure of data sources. And on your right is the product details screen. So we start with section 0, which is the status. And we begin our snapshot at the very least specific data source, which is the segmented data source. Now, in this case, these are actually the default metrics for the entire product details. And that's row height equals 44, background color equals light gray. That means everything is row height equals 44, background color equals light gray. So that's what we start with. Next, we move to the next most specific data source, which is the composed data source for details. It just so happens that it doesn't define any metrics whatsoever, not default metrics, not section-based metrics. So then we can move on to the status data source, which has section-based metrics specifically for that section of row height equals 60 and selected background color of medium gray. Because remember, we do the selection based on the actual color. So we have these overrides for row height, and we have a new attribute for the selected background color. So you can imagine if we had to go through this every time we move the origin of the collection view, we'd get a terrible frame rate. So it's really important that we only do this when it's absolutely necessary. So we only do it when the collection view changes. But then we go through and we update our attributes when we actually scroll. So I spoke earlier about optional layout methods, and this is where my whole confession comes in. I did these out of order. I know I spoke to some of you in the lab earlier, and I gave you some specific details. I started with initial layout attributes and final layout attributes. And I realized that, oh my goodness, in order to do initial layout attributes and final layout attributes, I need the update information. So let me implement prepare for collection view updates, and I'll just grab the array of updates. I'll just stash those over here because I need them. And each time I would get called for initial layout attributes, I'd walk the array and I'd try to figure out what was going on. And quickly my head exploded because it was just too hard. And I admit, I deleted all the code. I went on to other things. And it was weeks before I was willing to come back to it. And fortunately, in those weeks, I talked to a lot of people. I read a lot of the documentation. And I finally figured out what I was doing wrong. And what I was doing wrong is I wasn't doing my bookkeeping. I wasn't collecting the information that I needed. And so let's talk about that information. And more importantly, let's talk about the information in the right order. So this, it turns out, is the right order. Prepare for layout. You probably already implement this if you're doing a layout. But there's some information that we need to capture here, not just building our layout. And then prepare for collection view updates, followed by target content offset for proposed content offset, which is quite a mouthful, and then initial layout attributes and final layout attributes. So I'm going to talk about prepare layout and prepare for collection view updates together because they do sort of pair up. First, prepare layout. So here's my layout, very colorful. And when I get prepare layout, what I do is I take a snapshot of the current layout and I keep it as my old layout. In the process of building my layout, I have a lookup table between all the index paths to items, all the index paths to supplementary views, all the index paths to decoration views. Remember, I said keep everything. Well, when I get called for prepare layout, I duplicate everything, and I stash it as the old layout. Then, in prepare for collection view updates, I create a lookup table for deletions, insertions, and everything that was reloaded. And I run through the array of updates, and all the deletions get tracked, and all the insertions also get tracked. So now I know everything that's going on in my layout. And then, before I'm done with prepare for collection view updates, I calculate the delta in the height of the two layouts, as well as the change in where the offset of the start of my content should be. Because I've got content that's pinned and possibly scrolled off the screen, it gets a little bit tricky. And for the sake of the examples, we're going to ignore all that. But that all gets done right here before I return from prepare for collection view updates. So let's take a look at one of the other methods I didn't implement and later wished I had, the target content offset method. Now, the documentation says that this adjusts the scroll offset. And I didn't understand viscerally how important this was until I saw it in action. And so I have animations that are going to show you just how important this is. It's used by my layout, actually, to calculate the pinning offset and the delta that I use to prevent unwanted motion. And the trick is, I get this calculation correct, which took a little while, but then I use it in so many places. So let's take a look at exactly how that works. Before I implemented this, here I've got my old content, and it's 320 by 1000, and I'm scrolled all the way to the bottom. And I put in some new content, which is considerably shorter, and collection view, remember, does a lot of work for us. And it says, hey, that's not valid. I'll help you out. I'll adjust your content offset to 0,165, and I'll animate everything down for you. Well, remember, I'm not easy to please, and I don't want it there. I want to be able to see the new content beginning at the new content. That's kind of why I put it there. So that means to me that I need to change my content offset. So after implementing target content offset for proposed content offset, here I've got my old content, again with the original content offset of 0,432. And this time, I give a new content offset of 0,0. And notice, whoosh, everything slides down, and I can see my content at the correct position. But I'm still not happy, because my content shouldn't be moving. If you've seen the sample app, or if you've seen iTunes Connect, or if you've seen Game Center, you actually know that I wanted my content not just to come in, but I wanted my content to slide in from the side, because frankly, that's cool. And if I've got content that slides in from the top and slides in from the side, my users are going to get seasick. I don't want that. I'm going to get one-star reviews for that. So the solution is initial and final layout attributes. That function that I tried to do first is the final one that I needed to implement. And just a reminder, initial layout attributes is called if the view will be on the screen after the update. Final layout attributes is called if the view was on the screen before the update, and they're both going to be called for a view that remains on the screen. And I know you're not going to believe this until you see the code, but it's actually really simple once all the information has been processed. So let's look at some more animations before I let you see the code. On the left here, we see what's happening to the viewport. On the right is what the user actually sees. Okay? Without initial layout attributes, the blue content is stuck where it really is, and the viewport slides up to meet it. And that makes that unwanted animation. However, after I've implemented initial layout attributes, you'll notice that the new content is synced up with the viewport. And as the viewport transitions to its new location, the new content animates with it and appears to stand still. Now, everything's moving, but nothing appears like it's moving, and that's what's important. So let's take a look at the actual code. I promise you, it's actually really simple. So this is the first half. We start off by getting the section. Then we get a copy of the layout attributes. And obviously, we need a copy because we're going to modify them, possibly. And we don't want to modify the real attributes because then we'll be modifying the real attributes. And then our cells will be horrible. So then we determine whether or not this particular item was inserted or reloaded. Remember, I said we did all this calculation in prepare for collection view updates. And now that means we've only got these 2 lines of code. Then, if it was inserted, we change the alpha to be 0. So it's going to fade in. If it was reloaded and it didn't exist in the old layout, remember I created a snapshot of the old layout. So if there is no item at that index path in the old layout, when it was reloaded, we want it to fade in. It's perfectly okay if there was an item there the previous time, then it's just going to change. I'm okay with that. And then finally, we want to offset the origin of the item by the delta of the content offset. And that way, everything's going to stay exactly in place. So to recap, bookkeeping is critical to making your layout work. If you don't have the information you need, there's no way you can make these methods work. And then the optional methods really make a huge difference. They're the difference between a layout that technically works and a layout that's just great. So, middle 4 requirements. I think we did a pretty good job with that. The last 3, I thought were just going to be, a little something extra that we'd add to the application. And they changed from being a little something extra when they started to take a little bit of time. So let's take a look at them. In order to add swipe to edit, obviously we needed to add actions to our cells. And there's any number of ways we could have added actions. But in this case, we add them directly to the cells. And here we are, because we're going to use this as an example, we're adding 2 actions to a cell, make a favorite, and swipe to delete cell. You can see that each action has a title and a selector. Those selectors, when the action is invoked, bubble up the responder chain, and our view controller catches them. Now, for swipe to edit and batch editing and the whole 9 yards, we needed some additional custom attributes. We needed the column index, the editing state, and whether or not a cell was movable. And I think those will become apparent why we needed them in just a moment. So, for swipe to edit, with 1 column, this works exactly as you would expect, right? Swipes over, you get the 2 buttons, you tap on a button, action goes up the responder chain, view controller catches it, hooray, all's good. Now, in the case of the delete action, that's all handled by the base view controller. For 2 columns, it gets a little bit more complicated because just like Game Center, we wanted it to appear that our cell was sliding underneath the other content. And in order to do that, we needed to have the column index as an attribute on the cell. So when the column index is not 0, we display a little gradient, and therefore everything looks like it's sliding underneath. So for batch editing, we have an attribute for whether it's editing. And when that changes to no, we animate out our editing controls. And if movable is yes, then we also display the gripper. And movable is actually determined based on a query to your data source, or our data source, really. And as you would expect, you tap on the twisty thing, and out come the editing controls. And because I am much addicted to state machines, it is all controlled by another state machine. This manages all of our gesture recognizers, the UI pan gesture recognizer, the UI long press gesture recognizer. The states are somewhat complex. The diagram gives you an indication. The reason for that is that we have to respond to external stimulus. So for example, if you have a toolbar that has an edit and a done button that toggles, if you're editing and the user taps done, at any given moment we have to shut it all down and transition back into the idle state. And so that means that things are a little bit more complex. I'd love to revisit this and see if I can't, simplify it. But it works, and that's, a key criteria. It only works with our layout and our cells. I tried at some length to generalize it a little bit more, but it works, and that's a great feature. So drag to reorder. It required some layout changes. In order to make everything work correctly, we needed to add a layout gap. So as you're dragging this cell around, we needed to split apart the existing cells. And we also needed to take the cell that you were dragging and mark it as hidden. And we also needed to make sure that our layout calculation was fast enough. I'm not going to pretend that it's as fast as it's going to get, because I'm not done yet. But it was fast enough. It feels reasonably fluid. It's good enough for the first release. Now, it does require data source support. So by default, the data source normally answers, nope, you can't move that one. Nope, you can't edit that, so on and so forth. So in order to actually implement drag reordering in your code, you're going to want to say, oh, yes, you can move those things. You can drag those things. And so there are some methods on your data source that need to have the right responses. But it really was an incremental change to our layout and an incremental change to our data sources. So that's the last 3 requirements. And they were a little bit of a challenge, but they were just, a little bit extra. So in summary, the aggregate data sources went a long way to simplifying our complex designs. When I first saw the designs that HI gave us, I was a little bit terrified. There was a lot there. We had a very short time. And I'm glad that we found a way to make it easier. And for UI collection view, bookkeeping, bookkeeping, bookkeeping. Keep all the data. Don't let it out of your sight. At the very end, when you're concerned that you're using too much memory, fire up instruments. Let instruments tell you if you're using too much memory. And then finally, swipe to edit, drag reordering. They're just incremental things. You can do it. And they're sample code. Pull it out of there and make it part of your own. So for more information, talk to the incomparable Jake Behrens. I'm told he has great shoes. Documentation, take a look at the iOS documentation online and the dev forums. There's great material there. We've been known to hang out there as well. There were related sessions this morning. I'm sure they'll be online this evening. So thank you so much for coming, and I hope you enjoyed this evening.